Hello boys and girls, we're working with quadrilateral lesson 13. Revision of what we have done. A quadrilateral is a closed figure. The angles in a quadrilateral add up to 360 degrees. There's the angles here, they all add up to 360 degrees. We're going to use that fact today. Now we also learned with the quadrilaterals the properties. We have a palm or parallelogram, opposite sides parallel and equal, and opposite angles equal. A rhombus, special palm with all four sides equal. Rectangle, the special palm with each angle being 90 degrees. Square, the special palm with all four sides equal and each angle is 90 degrees. Kite has adjacent sides equal and one pair of opposite angles equal. Note which pair of opposite angles are equal. The one between the non-adjacent sides. Now, trapezium has one pair of opposite sides parallel. So for today, we're going to look at how these properties are going to be used when calculating sides and angles of quadrilaterals. Now, when given a question, you need to identify the type of quadrilateral that we're working with. So in this case, we're working with a parallelogram. The easiest way to solve for the unknown sides, like we have AD, we need to find BC, we need to find AB, we need to find angle D, as well as angle C. The best way to work with those is mark your properties. So we know that this side here, opposite sides of a palm are equal. We also know that the opposite sides of a palm are parallel. So by marking this, it makes it easier to work, to find the answer. So if this is 7, it means that this side should be 7 as well. Now these pairs, as both the opposite sides are equal, so this pair is equal as well. So this side is equal to that side. We can mark it parallel, although we're not going to use that immediately. We need more the fact that they are equal to help us, because if DC is 3, then we know that AB is 3 as well. So write 3 here for AB. So 7, 7, 3, 3. Opposite sides equal. Now we also learned that the opposite angles are equal. So if that is 70, angle D should also be 70. And if this is 110, then this should also be, angle C should also be 110 because the opposite angles are equal. So these two angles are equal, B and D are equal, and A and C are equal. So in answering our questions, we started with angle C in this example here. In the solution, we need to solve for C. So C is equal to angle A, which is equal to 110, opposite angles of a parallelogram. Then you're working with D. D is equal to angle B, which is equal to 70 degrees. So D is 70 and C we had 110. Both reasons, opposite angles of a parallelogram. BC, there's BC. BC is equal to AD, which is 7 centimeters. And then we have AB equal to DC, so it's equal to 3 centimeters. So you can mark the equal sides and angles in your diagram. Makes it easier to form your solution. The solutions must have a reason. Just remember as well that AB is parallel to DC. So ABCD forms a U shape. Right, so I'm going to clear this and show you. Since AB is parallel to DC, if we needed to solve for C, so we have this angle marked. Remember, we can mark the angle that's given. And then we need to find C. We need to find this angle here. So C is created by the angle lines DC and BC. Because AB is parallel to DC, we actually have your co-interior angles. So we could have found C by saying 180 minus 10, which would have given you 110 degrees. And remember, if it's 110 degrees, we use the reason in our case, angle A is equal to angle C, or angle C is equal to angle A, 110, opposite angles of a palm. But we could have also used co-interior angles, just to show you that there are co-interior angles here because these two lines are parallel. That is a possibility. But for now, we are using the properties of a parallelogram, which makes it easier to work with. But when you answer an application, any valid reason is acceptable. Look at example 2. We identify that this is a kite. Given here as a kite. So the properties of a kite, we know that the adjacent sides are equal, which means this side here is not equal to that side. So if this is 8, then this should also be 8. And these are the adjacent sides here. GF is adjacent to EF, so these two sides are also equal. So using that, if this is 8, it means this side will also be 8. And if this is 4, the side will be 4. Next, we need to look at the angles. We need a value for angle G and angle E. We have D to be 45, we got F to be 100. Need to change this value here for F. It's not 100. F's value should actually be 99. If you look at the solution here, we use 99 for F. So let's change this to be 99. And so F is 99. So we have these two values, but we don't have a value for G, and we don't have a value for E, but we do know from the properties of a kite that G is equal to E. So to work this out, the angle, sum of angles of a quadrilateral is 360. So 360 degrees, take away the value of these two angles, which together add up to 144. 99 plus 145 is 144. So 360 minus, take away these two angles of 144 in total, will give you 216. If this is 216, then G and E are equal. So 216 divided by 2 will give you 108 for each angle. So that's how the values for G and E need to be worked out. And the method and how it's given here, let's watch how it's done in our method. Right, we have D, E, F, G is equal to 360. So all the angles, D, E, F, G add up to 360. Reason, sum of angles of a quadrilateral. We have a value for D, we have a value for F, which we write down in its place. We don't have values for E and G currently. So E plus G and 45 and 99 gives you 144. So E plus G plus the 144 is 360. So E plus G is equal to 216, which is 360, take away the 144. Remember, we did in algebra, plus 144 moves across the equal to sign, it's minus 144. So 360 minus 144, it gives you 216. Now angle E is equal to angle G. The values for these two angles are the same. So we divide by 2, so they're 108 degrees each. Now this is the step-by-step method. You can do it in shorter methods, but you have to ensure that you have the sum of the angles of a quadrilateral is equal to 360 as a reason. And you must have the reason opposite angles of a kite when you state that angle E is equal to angle G. So these are the two valid reasons that need to be used when you work out an example like this. So we use sum of angles of a quadrilateral and we use opposite angles of a kite to find your solution. Your application, here we need to find the sizes of the angles marked A, B, C, D, or E in all these diagrams. So you identify the type of quadrilateral here, and that should help you solve for these angles. Remember, we can use congruency where necessary, not congruency, you can use parallel lines where necessary. The FUN, if it's possible. F, corresponding angles, U for co-interior angles, which are supplementary, and N for, or Z for, alternate angles. We look at this, you can see there is an F here. Just to give you an idea, I do see an F here, which can, which can be used, the F can be used in your application. You can also use the concept of co-interior angles because we have parallel lines throughout. Because your figures, your parallelogram, your rectangle, your square, your rhombus, all have parallel lines. So you can use that. You can use what you've learned in parallel lines. You can use sum of angles of a quadrilateral. You can use you can use a straight line as well if you need to solve for something. And there is a straight line here. So there are many mathematical terms that you learned over this past few weeks that you can use to solve for A, B, C. If you are using angles that are not numbered, you can redraw and you can number them or you can label them. For example, if you needed to label that one, you can do so. It's called PSR, angle PSR. That is also an option if you need to use it. There's more than one way, so you may not need that. Using corresponding, you can work out C and you can work backwards to B and A. So there are other examples here that you need to look at. All these examples you will try. Remember, you need to know the type of quadrilateral it is. Mark the other properties of the quadrilateral. So if you identify, for example, a rectangle, then mark them parallel because you may want to use something about parallel lines and so on. In this example here, you're going to work out the value of X in each of the quadrilaterals. So you don't need to work at the side, you need to work out the value of X, solving for X. You may complete the application.